Hello everyone, today we'll be learning stoichiometry. It is more commonly known as moles. It is both math heavy as well as calculation intensive. So when doing stoichiometry questions, please remember to bring along both your calculator as well as your periodic table. Stoichiometry is an important topic in both secondary school as well as JC. It also has value in other chemistry topics such as energetics and organic chemistry. So it is very important to have a firm understanding of stoichiometry as it will form a foundation for other chemistry topics as well. Now, without further ado, let's get started. Firstly, we will be going through the key terms. Key terms are important to memorize for two reasons. Firstly, definition questions in exams are very easy to score. Definition questions include, please define what is relative atomic mass or define relative molecular mass. These questions can range between 1 to 2 marks and are very easy to obtain if you simply memorize the key terms. So please do pay careful attention and memorize them because we want to make sure we can easily secure these 3 marks. On top of that, key terms are important to memorize because it helps in us to understand the concepts better. By having a firm understanding on what is relative atomic mass, for instance, we will better be able to apply the concept and also better be able to understand questions which involve the concept, be it in both calculations as well as planning. The first definition is relative atomic mass. Relative atomic mass is defined as the number of times the average mass of one atom of an element is greater than 1/12 the mass of one atom of carbon-12, and it is defined by the symbol of Ar. It is important to note here that relative atomic mass is relative, meaning it is not an absolute value. Relative means a comparison between the average mass of one atom to 1/12 the mass of one atom of carbon-12. The next definition is relative molecular mass. As you can clearly see, it is defined as the number of times the average mass of a molecule of an element or compound is greater than 1/12 the mass of one carbon-12 atom. If you recall in lower level chemistry, a molecule is simply defined as two or more atoms chemically joined together. There are molecules of elements such as H2, which is the molecule of hydrogen gas, and there are also molecules of compounds such as NH3 or ammonia gas. Now, if you look closely at relative molecular mass and its definition, you will find that it is quite similar to the definition of relative atomic mass. This can be seen in the fact that for relative molecular mass, we are comparing the average mass of a molecule, but for relative atomic mass, we are comparing the relative mass of an atom of an element. But overall, it is still a relative comparison between the mass of something and the mass of 1/12 the mass of a carbon-12 atom. Relative molecular mass is denoted by the symbol of Mr. Next, we shall discuss why we use the word average when it comes to talking about the mass. So the reason we use the word average will be clearly stated in the section below. I shall use chlorine as an example. Here we have an icon of chlorine which you will typically found in the periodic table. It has the symbol of the element Cl, the name of the element itself, chlorine, the atomic number or proton number of 17, and the mass number of 35.45, which can be rounded up to 35.5 with 1 decimal place. The reason we have used the word average is due to the presence of isotopes. If you remember, once again in lower level chemistry, isotopes are defined as atoms of the same element with the same number of protons and electrons, but different number of neutrons. The two isotopes that are most common for chlorine are chlorine 35 and chlorine 37. To do a quick recap, because the number of protons for chlorine is the same, that means chlorine 35 and chlorine 37 both have 17 protons. That easily means you can calculate the number of neutrons for chlorine 35 and chlorine 37. Chlorine 35 has 18 neutrons, while chlorine 37 has 20 neutrons. The bracketed numbers next to each of the isotopes are their relative abundance. Relative abundance signifies the percentage that you will find each isotope in nature, meaning that if you were to find a sample of chlorine in nature, 75% of it is likely to be chlorine 35, while the other 25% of it is likely to be chlorine 37. By using these relative abundances, which are the percentages, and the mass number of the isotopes itself, we can find the average AR, or average relative atomic mass for the chlorine atom, using the formula below. 25% times 37 plus 75% times 35 gives you an average relative atomic mass or relative mass of 35.5.